Question 3. Pia runs 2 kilometers every day and her times in minutes are normally distributed with a mean of 10.1 and standard deviation of 1.3. So if this is normally distributed with a mean of 10.1 and standard deviation of 1.3, so we write this as mean and variance standard deviation squared, so 1.3 squared. Find the probability that on a randomly chosen day, Pia takes longer than 11.3 minutes to run 2 kilometers. So we have to find x is greater than 11.3. The probability that she runs greater than 11.3 minutes. So the first thing we need to do is we need to standardize this. If we standardize this, we have this as z is greater than 11.3. 11.3 minus the mean value upon the standard deviation, which is just 1.3. And that gives us the z value of greater than 0.9231. Yeah. So this is z being greater than this value. If z is greater than this value, we do 1 minus phi of that value is 0.9231. And remember, this is the z value, which we have to look up in the table. So if we can have the normal distribution table over here, we will go for this value 0.9. We are going to go in this column 0.9 and then 2. 2 is right over here, 0.92. And then we have 3. 3 is 8. So we get 0.8212 and we're going to add 8 to this. So if we add 8 to this, we get 0.822. Now coming back over here. So we got the value as 1 minus, we looked up this in the table and we got the z value as 0.822. So 1 minus this value is going to give us a 0.178. And that's our answer to part A. Part B, it says on 75% of days, Pia takes longer than t minutes to run. So she takes longer. So that's the z value, longer than t minutes on a certain day. And that's given as 0.75. That's the probability, which is 75%. On 75% of the days, Pia takes longer than t minutes to run 2 kilometers. Find the value of t. So we have to work out the value of t now. So, and this would be given as x first, and we will have to standardize this to find the z value. Okay, so let's suppose this is given as x. So if we standardize this first, we'll have this as t minus 10.1 over 1.3 using the values from part A of the mean and the standard deviation. Now this is greater than all of this, whatever the value is over here, and that's given as 0.75. Now, like in part 1, we know when this is greater than, when we have pz is greater than a, we do 1 minus phi of a. But over here, if I do 1 minus 0.75, I will get 0.25, and 0.25 I have to look up in the table. And my normal distribution table, the first probability that I get in the normal distribution table starts from 0.5. And remember, this is the probability that's given. So we have to do inverse of phi. We have to look reverse backwards in the table. So that's not going to be possible. So if we do 1 minus, in this case, we can't do 1 minus. We'll get 0.25, which won't give us any value in the table. So for in this case, that means this is greater. And in what case we do not, if even the sign is greater, in what case we do not do 1 minus. So that is when we have probability of z being greater than with a negative a. Then we do not do 1 minus a, we just do phi of a. So that means this whole value has to be a negative value. So if I look up in the table of 0.75 value, so 0. So basically I have to do phi inverse of 0.75. This is the value I need from the table. And remember this is phi inverse. So 0.75. So where do I get 0.75? 0.75. Well, the closest I can get is over here, 0.67, 0.67, and I add 13 to this, and I'll get the closest value. So that's going to give me 0.674. 0.67. This is the value I'm getting. And then I'm adding 13 to this. And that's going to give me the closest value to 0.75. Now going back to the question. So from the table we got this. So this is now t minus 10.1 whole thing over 1.3. And we looked up this value in the table as phi inverse, and we got this as 0.674. Now we know, like we said, we know that this whole value has to be negative because this has to be probability of z being greater with a negative a sign. And that's just going to give us phi of a because we can't do 1 minus. If we cannot do 1 minus when we have a greater sign with a negative sign. So that's going to give us, since this whole thing is negative, I can have a negative sign right over here, or just to make it easy, I can have a negative sign over here. So I'm having a negative sign over here. I'll put a negative sign over here instead of putting it over here. That's just going to make the calculation easier. So that's t minus 10.1 being multiplied by minus 0.674 and minus 0.674 multiplied by 1.3. You cross multiply and you take this over there, and now you're working out this value for t. If you solve this for t, you'll get this as 9.22. That gives you the answer, the value for t. Now there's another part to this. On how many days in a period of 90 days would you expect Pia to take between this 8.9 and 11.3 minutes to run 2 kilometers? So how many days? So number of days we need to find. That would be the probability being multiplied by in a period of 90 days, multiplied by 90. So that means we have to work out the probability first. We have to work out the probability for the given range of 8.9 to 11.3. So we have probability of this as x being between the values of 8.9 and 11.3. Now first we standardize this. So we convert this into z values, z, and this is going to be 8.9 minus 10.1. It was 10.1. We got the mean as 10.1. 10.1 was given to us, 8.9 minus 10.1 divided by 1.3. And this is 11.3 minus 10.1 over 1.3. So we get this as the values we get as 0.9231 and 0.9231 we get on both the sides. So that's going to give us a negative value. So that's going to be probability, I'll just write over here, probability of this being minus 0.9231 Z, and this is positive 0.9231. That's the positive value, this is the negative value. This is, remember, this is phi of minus b, and this is minus a and b. I usually write this as a. You can write whatever you want. So I just take this as A, and this is as B. So if this is the condition that's given to us, we do phi of B minus 1 minus phi of A. That's what we're going to do. We are going to do over here. And in this case, both are A's because both the values are the same. This value and this value is the same. So once we do this, we get this as phi of 0.9231 minus 1 minus phi of 0.9231, which we get this as, if you open the bracket and multiply the negative sign, we get this as 2 phi with the same value being added up. That's why we get 2 phi minus 1. Now we look up this value in the table of 0.9231 and we see what we get. So 0.92, 0.92, that's right over here. That's right over here, 0.92 and 3. So 3 is going to be 8. So we're getting the same value, 0.822, like we got before. So that's going to be 2 times the value we are getting from the table, that's 0.822 minus 1. And we get this, the property as 0.644. Now we had to work out the number of days, and we did number of days over here. Number of days is equal to probability times 90. So we have got the probability as 0.644 being multiplied by 90 days period. So in a 90 days period, if she has this probability times 90, that's going to give us 57 days. And that's the answer.